I want you to think about names. When you see water, you already know what's it called universally, right? It's just water. Or when you see salt, we all know it's called salt. These both have special names as well. For water, it's also known as dihydrogen monoxide, and for salt, it's also known as sodium chloride. But the real question is, how do we even get to these special names? It turns out that it comes down to the amount and type of elements in a substance. Ionic compounds are composed of at least two different elements. There usually is a metal and a nonmetal. There are also a few rules. The first rule is that all metals should be written first and nonmetals are afterwards. Secondly, all the names of compounds that have only elements end in "ide." Let me give you an example of salt. Salt, or NaCl, is an ionic compound because it has a metal and a nonmetal. Na, or sodium, is a metal, and Cl, chlorine, is a nonmetal. Following the rules, the name of NaCl is sodium chloride. The metal goes first, followed by the nonmetal, and there's the "ide" ending. Let's do two more examples. I would take a piece of paper, pause, and jot down your answers. K2O should be potassium oxide. Potassium is a metal and oxygen is a nonmetal, so potassium should go first and oxygen should go last. MgCl2 is magnesium chloride. Magnesium is a metal and chlorine is a nonmetal, so magnesium should go first and then chlorine. Transition metals might be in the formula of ionic compounds as well. On your periodic table, the transition metals are the elements in the middle block. You're going to do the same thing like any other ionic compound, but after you name the metal, write parentheses with the metal's charge as a Roman numeral in there. For example, let's look at this ionic compound. Fe is iron, a transition metal, but we don't know the charge of the transition metals. Fortunately, we can find out that by looking at the charge of chlorine. Chlorine is a group 17 element with a -1 charge. There is a 3 subscript, which tells us that there are 3 chlorine atoms. In every single ionic compound, the charges must cancel out. So there are 3 -1 charges, and we will have to find what plus -3 is equal to 0. That would be +3, so iron has a +3 charge in this scenario. Start with the metal, iron, then add the parentheses with a numeral 3 inside because there is a +3 charge. After, add the nonmetal with the ending "ide." The answer should be iron 3 chloride. The first answer should be copper 1 oxide. Oxygen has a charge of -2. To balance it out, the 2 copper atoms must split a +2 charge, meaning that each copper ion has a +1 charge. The second answer should be lead 4 oxide. Each of the 2 oxygen atoms has a -2 charge. 2 times -2 is -4, so the 2 oxygen atoms carry a -4 charge. For the charges to cancel out, lead must have a +4 charge because the 4 plus -4 is equal to 0. Chemical compounds with polyatomic ions are ionic compounds because polyatomic ions have a charge. The charge could be either positive or negative. Your teacher may give you a reference sheet of polyatomic ions or may just tell you to commit them to memory. I'll list some common polyatomic ions on the side just in case. This time, put the cation, the positively charged ion first, and then the anion, the negatively charged ion. For this time, depending on the anion, the ending isn't always "ide." Polyatomic ions can end in other ways like "ite" or "ate." Let's do an example. Na2SO4. First, identify the cation, which is sodium. Next, look up or recall the polyatomic anion, SO4, which is sulfate. Put them together without changing the polyatomic ion's ending, and you get sodium sulfate. In NO3, nitrate is an anion because it has a charge of -1. Calcium must be a cation. Calcium should be written first because it's a cation, and then nitrate. Your answer should be calcium nitrate. For the second question, The polyatomic ion is the cation because ammonium has a positive charge of 1, and it pairs up with a sulfur anion. The anion isn't a polyatomic ion, so we use the ion ending. The answer would be ammonium sulfide. A molecular compound is a chemical structure with at least 2 elements that are nonmetals. This time, prefixes are going to be used. You may need to commit this to memory as well. Mono means 1, di means 2, tri means 3, tetra means 4, penta means 5, and hexa means 6. The last element will still be ending with "ide", however. Based on the number of atoms, use the prefixes to show how many atoms of a specific element there are. Remember I mentioned water? We all know that water is H2O. There are 2 hydrogen atoms, so we should first write dihydrogen because di means there are 2, and there are 2 hydrogen atoms. Then there is 1 oxygen atom, so after dihydrogen we would write monoxide because mono means 1. However, do be careful on using vowels as well. Some students might write monooxide, but this will be grammatically wrong because there can't be 2 vowels, A or O, next to each other. In this case, just drop the vowel of a prefix if it ends in A or O. So it would be monoxide, where we drop the O in mono. 1 carbon atom bonded to 2 oxygen atoms. Anytime the first element only has 1 atom, skip mono for the first element. It's carbon, not monocarbon. For first elements, only put a prefix if there is more than 1 atom. N2O5 should be dinitrogen pentoxide. 2 nitrogen atoms, so we use the prefix di, and 5 oxygen atoms, so we use the prefix penta. So it should be dinitrogen and then pentoxide. Thanks for watching. If you want more practice, you could also search it up on Google. It offers a lot of practice problems.